Welcome everybody to the inaugural episode of Databased. This is where I get to host and chat with Jamie Turner and James Cowling, the CEO and CTO, respectively, of Convex, about all of the interesting things that are happening in the web development industry, and especially around databases and infrastructure. James and Jamie both had integral roles at Dropbox, helping scale out their infrastructure over the previous 8 years. Forever. That's right. And today we have a fun topic. Today we have a topic that's been in the Twitter sphere recently quite a lot, and that is that of the edge. A couple of years ago, it felt like the edge was the be-all, end-all solution. It was like you have a data center up the road from me, and then I think people tried to do a lot with it, and now they're paying for that. I'm not really sure exactly what's going on, but that's what I would like to clarify with you both. And before I hand it off, Jamie, I dug up this quote from you from over a year and a half ago, January 2023. And it says, "The new intruder we're rolling our eyes at is the edge. The edge is nothing like the cloud. It's mysterious and it's mysterious and coming for us. Everyone is starting to say it, and we're starting to feel inadequate that we're not using it enough or talking about it the right way at parties." So that, I think, is a great encapsulation of where the edge was a year and a half ago. How does that contrast to the conversation that's happening around the edge today?
Well, all I know is I'm massively disappointed because I was promised that there was going to be a server closer to me than my mailbox, and that didn't happen somehow. So I think the server's still a ways away. I don't know. Everything's still in Virginia. I don't know how it panned out, but yeah, I think there definitely was a thematic fervor about the edge. The edge is a big deal and stuff like that everybody was really excited about a couple of years ago. And I think that maybe one of the ways the discourse has changed is that some of the complications and the limitations of first of all, maybe a little bit of clarifying, people discovering what did we actually mean by the edge and how were we going to do anything with it once a lot of the frameworks and stuff landed, where edge computing began to be a thing in everybody's purview. Everyone was taking it on. And then as we began to actually try to build with it, the limitations and complications of the edge started to become a little bit more apparent and started to take a little bit more of a toll on everyone's enthusiasm. So I think because of that, there's more complicated feelings now about the edge maybe than there were 2 years ago.
I feel like there's there's buzzwords, there's hype, there's exciting topics, and then there's just reality. There's just laws of physics, there's speed of light, and there's just foundational truths. And I think when hype runs up against foundational realities, that's when growing pains start. I think, and that's what's happening right now. But it might make sense to start with just defining what even the edge is.
That would be helpful. I feel like I have 5 different definitions or ideas of what the edge is, or it's like the cloud, right? So what exactly is it? What is the edge?
I can take a shot. So it's not a new idea, but it's relatively new as being hot with respect to web programming. So you think of the internet as a network, and the core of that network is the data center. And Jamie said earlier, Virginia. Yeah, your data center is probably in Virginia, right? And US East 1. That's where most of them are, right?
It's picturesque there. The data likes it there. It's quite beautiful.
Best place. Yeah. I'm sure great tax treatment. And so your data is probably there, right? And that is the data center. That's the cloud. So the cloud is a big bunch of servers somewhere. And the edge is the edge of the network. It's the part of the network closer to you. So you can almost think about it almost like the last mile, right? And so
it's like the outside walls of the data center.
Well, it's much closer to you than that, unfortunately. So the data center. So the data center is maybe it's 30 milliseconds away from you if you're in the United States. It might be 200 milliseconds away from you if you're in another country. And the edge is some server sitting in an ISP or a colo much closer to you, right? It's probably 5 milliseconds away from you, or maybe it's 10, depending on where you are, or a little bit more. So the edge is this idea that you don't have to be beholden to the cloud, in a certain location in the world. You get to have servers really close to you, and by virtue of having servers close to you, everything becomes faster, latency becomes lower. Oh, wouldn't it be a great idea to, instead of having everyone's data in one place, have everyone's data really close to them so they can interact. And there's a lot of reasons for this, and we can talk more about why this is relevant to web development and how this relates to React server components and all this kind of stuff.
Mm-hmm.
I think I'll just to kind of, not foreshadow, I think, what Jamie and my take will probably be in this recording is that at the end of the day, your data has to live somewhere. And if you have a collaborative application, the data that you share with other people has to live somewhere. And ultimately, the source of truth has to live in a single physical location, not a virtual location. It has to live in an actual physical location on Earth. And the speed of light takes some amount of time to get there. And so there's this tension between like the back-end store, the cloud, the database, and a server somewhere, where generally the authoritative version of your data is, and the edge, where maybe your code runs, maybe some secondary kind of cached version of your state is at.
And I just realized I'm really jealous now of everybody in Virginia. They've had the edge this whole time. Like, you lived in Virginia, you've had the future. Like, I don't know if everyone in Virginia knows it. They've had like the future we've all been working toward this whole time.
That's just like
in the government don't use server components because AWS is next door.
That's right there. Just move near AWS and your problems are solved,
So is this the right way to think about it? Like what you just said. So we have servers scattered around the world, or like they're in your city. They're very, very close. Why can't we have our databases there? Is that because if I was the one hitting the database, that's great. But if I'm playing a game or chatting with somebody in Italy, they still have to come all the way to my edge. It's not their edge anymore. It's my edge. Is that that's the contention, in that I guess you can't have a single source of truth database spread across multiple physical locations?
There has to be a physical point of reconciliation between multiple participants, right? And that can be distributed around the world, or get, via gossip protocols or sync protocols. But at the end of the day, if you and I want to collaborate on something, or if we want to make a purchase of an item on a store, and it matters that we have a consistent view of that state, i.e. like we both see an accurate version, there has to be a single physical location where that transaction occurs. That can be anywhere, but it has to be somewhere convenient to everybody else. And so, there's this kind of, people say these, there's two hard problems in computer science, naming and cache consistency, I think. Or maybe they say it's two hard problems, naming cache consistency, and off by one errors.
Yeah.
And we'll talk more about this in a minute, but when you start putting data in different places, you start dealing with some very, very difficult challenges around cache consistency. Which location actually stores the accurate, current, authoritative version of your state? And this problem is so hard that almost everyone just stores data in one location and then maybe caches it elsewhere.
Yeah, I think to the question you're asking, wouldn't it be wonderful if we could all just store our data right next to us, right? But the challenges from that come from the fundamental value the internet provides. It interconnects all of us, right? And so the ability to transact about as well with someone on the other side of the world and someone, our next door neighbor, is one of the benefits of the internet. And so the internet software is all built that way. It's mostly assuming a fully interconnected world. And in that world where you can conduct transactions more or less with anyone, at the end of the day, there needs to be some way to reconcile when two things happen. They eventually have to be brought together. And then once you do that, you've brought physics back into the equation, right? So data takes time to travel. It's mostly light in optical cables, and light is fast, but not instant. And so it's very difficult to fundamentally avoid the need to actually have your data travel relatively far in order for it to bring you the value of combining that data and transacting that data with the entire planet, which is what most people's expectation of software is these days. So yeah, there's these very large trade-offs associated with trying to do too much with the edge, in that at the end of the day, the thing that matters the most is the data and the kind of universal ubiquity and access to the data.
Right. It sounds like the use cases that you're both alluding to revolve heavily around transaction consistency and concurrency. Are there use cases in which it would still make sense to have replicated data, or is the fact, like, are databases inherently expected to support those concurrent use cases, and that's final.
Yeah, I think maybe you're alluding to just the concept of caching, which is, it's been a concept that's been around forever. So if you think of a company like Google, right, they have a very, very sophisticated, very, very complicated infrastructure. But at a certain point, when you make a change to send an email or change some account credential, that is going to a single physical location to be done. But for example, when Google's running their ad network, and they have ad servers all around the world, they just keep some cached, stale version of ad state, right? That stores, who the advertisers are and what they want to bid on. So there's plenty of situations where there's state that can be stale, that can be old. Push that out as close as you want to either the end user or the service close to the end user. But when it comes to authoritative transactional state, which, by the way, is the state that often is the hardest to deal with for web applications, that typically always lives in a single physical location, and it's in the cloud, which means it's probably in Virginia, or maybe it's in Oregon. It's in one of those places.
Right, all those Virginians that are on the edge all the time, they've got all the data there. Yeah, I mean, the to James's earlier point, right? The edge is not actually a new concept, but it's a new concept maybe that application developers are suddenly finding themselves needing to be involved in. It's maybe a benefit, maybe a liability. It's at least intriguing, right? It goes to the classic successes of the edge, because the edge has been around for quite a while, and those are terminating SSL, right? So terminating TLS, there's this little handshake that has nothing to do with database state, and it requires several round trips to a server. And if you can conduct those 5 milliseconds away instead of 150 milliseconds away, then that has an appreciable impact on how quickly you can start getting the website data. And the second use case that's been quite old and extremely successful is what CDNs have done historically, which is utilizing the edge to put mostly static assets onto the edge, things that don't update very often, things for which a slightly delayed consistency is completely okay. And then you get this enormous performance benefit by being able to pull down, let's say, all the images and things like that don't change very often on a website from the edge. So right. I think the thematic differences in the last few years are somehow trying to bring more of the business logic, application specific sophistication into playing a role in the edge, and having application developers being sort of brought in to say, you're going to be involved in this process here, and this is going to be a benefit to you.
Maybe if you use an example of like a certain common application, like a text editor, right? In the old days, there was, say, Microsoft Word, and you ran it locally on your computer, and you stored the files locally on your computer. You're on the edge, right? Your laptop is about as edgy as you can get, right? That's as far away from the data center, but there's no sharing, right? And if you wanted to share files with someone, you have to send it to them, right? So then to move from that kind of single player mode to a multiplayer version where you can collaborate on a doc like you would in something like Notion, right? The first step you would say, well, let's run the whole service, the whole application in the cloud in Virginia, for example, right? And that works pretty well, but maybe it's a little bit slow on initial page load, because maybe having to send all that JavaScript and HTML down to your web browser takes a little bit of time the very first time you load the application. So sure, why don't we serve that data from a cache, right? And so this is what everyone does, right? If you deploy an app to, even before we started talking about the edge, deploy an app to Netlify or Vercel or your HTML via a CDN on Cloudflare, you're fetching the web app from a server pretty close to you, right? So that's caching. I guess that's the edge, right? But then the next step, so now you've downloaded the HTML from a service near you, and now you have to actually go and commit your rights. Your keystrokes have to go to a service somewhere, right? And you have this decision now. Do you have those keystrokes go all the way to a server somewhere in the cloud and deal with some latency, but have a relatively simple protocol because all the rights are coming into one location? Or do you have every participant in this shared document be writing to a server near them with low latency, and then somehow in the background, via some degree of magic, reconcile all of the versions of the state? Now, there's special algorithms that have been developed just for text editing that solve these problems. But this is where we're kind of at with web apps and the edge. It's saying, hey, we've used caches and CDNs to speed up initial page load of this HTML. That worked great. can we apply that same stuff to have all your compute running near you as well? And it's a nice idea in theory. Where the idea becomes really difficult, like I alluded to just now, is when that compute needs to talk to data. Because that data is probably going to be, in a central server somewhere. And then you have to ask yourself, are you getting that many benefits from talking to a compute service that's close to you, but is issuing many round trips to a database far away? Or should you just talk to an API service that's really close to your data? And I think people are finding in many cases it's much simpler and actually more performant to have your code co-located with your data, where there's a lot of many rounds of tight loop kind of communication, and have a little bit higher latency between you, the end user, and your API service.
Okay, so I wanted to maybe ask, maybe it's a bit of a naive, stupid question, but we're talking about data existing in one physical space. Can you do this thought experiment with me where we take that database server and physically make it bigger? I mean, it's a board that's attached to components with wires. What happens if that board is physically, hypothetically, big enough to like be in both places? Like, what is stopping that from being just as fast as being able to reach the Virginia through a wire or through fiber?
Right. Well, I mean, electricity passes on that giant board, and light passes across that network. So that board would be so enormous, it's subjected to the same fundamental kind of speed of light limits as everything else. It was just very interesting, right? In that, like, to get, in general, the rule of thumb is you can get an optical bit of data, from point A to point B about half the speed of light or so maybe twice as slow. And so if you do the math on that, because the Earth is not that small, then getting it across the United States is going to take 50 milliseconds or 55, and getting it from Virginia to Japan is going to take like 160 or 180 minimum, 200. And so you do all the math on these things, and unfortunately you kind of run into physics. So even if it were one giant board instead of a bunch of optical cables, physics would still be in your way, in that, electrical charges that represent data can only move so quickly through the medium. So
when we talk about large-scale distributed system, building large-scale distributed system, oftentimes in the meetings, we start saying things like Jamie is saying, like, we're running into the laws of physics. And that is not a metaphor, because it may be something people don't deal with in their regular lives that often, that like the speed of light matters. This is not that technology hasn't advanced beyond a certain point in time. It's that fundamentally, as far as we know, nothing in the universe travels faster than the speed of light, and it can't. Right. So it's just not possible to get a message from Sydney to San Francisco in less than around about 100 milliseconds, I'm guessing. I actually don't know. It's probably about 100 milliseconds. Could be 200. Because that's just how fast light can travel. And that's about as fast as, electrons can travel.
Why are we even trying to solve this problem then? Like, is that not just a fundamental limit? If you want to have an application that people in Australia use and people in the United States use at the same time, and they're interacting with the same data, that is a physical, fundamental limitation.
Yeah, so I mentioned earlier, and actually I'll turn over to Jamie because he's actually more experienced about this than me, but there are techniques to avoid this. Like, one is CRDTs, which I think stands for conflict resistant data types. So there's data types that are designed such that they don't require like actual strong synchronization. You can just kind of this is very common in Google Docs, for example, right? You can both just be typing, and eventually Google Docs decides an order for the characters of the different people. Mm-hmm. And it just works out. But in general, when there's most use cases are not actually solvable via CRDTs. Most use cases, you have to, if you purchase an item on eBay, there has to be a piece of code somewhere in that system that says, Tom now owns this item, right? That has to happen in a single physical location. The only way now you can say, let's just let Jamie and Tom both have it at the same time and then refund one of them, right? That logic is very complicated. But at the end of the day, interaction, and that's what the internet is all about, and why a web app is on the web and not just the software on your computer. It's about communication. It's about interaction, and that has to happen in a single physical location. There's no way around it.
Yeah, I think the question you're asking is in some ways a little related to where are the places that edge compute does work, right? And like there are some circumstances, right? Really specialized circumstances where the team is opting into utilizing a particular kind of job on the edge. Similarly, when it comes to the storage stuff James is referring to, there are ways to model data and data coming together and data being reconciled using semantics that are compatible with, let's say, pretending that you've committed your right when you talk to the edge, things like CRDTs, and then you can bring these data structures together later, and they have kind of a sound way to resolve the separate transactions. The problem is, and I say this from experience, having built a few of these before, is that a lot of applications start out saying, "Oh, I can model my whole app using just that," and then they start building around this assumption they're going to commit to the edge or it will be fully offline. And most applications, if they live long enough, in my experience, they eventually need true transactions. Almost every application eventually, getting back to physics, runs into there's just something that cannot be expressed by the more limited semantics of something like CRDTs. It just needs plain old ACID transactions. And it's very difficult after you've committed yourself to this architecture to kind of work your way back to a more centralized traditional architecture. And I think that's ultimately why it's a little bit more of a pointed take on this situation. Very few applications, the trade-offs are worth it, to be honest. It's usually, in general, better to just start with store your data all in one place, use a traditional ACID database, and then as time goes on, the whole like you're not going to need it or don't prematurely optimize, you'll find things like, oh, you can push cache values at the edge and stuff like that. It's much better later to opt in if you run into one crazy performance problem that you can really dive into and say, hey, there's a way for us to model this where everything is still correct and the performance will be way better and it matters for this subset of our application. Then I think that's the right point to start thinking about edge compute. Earlier than that, it's almost never worth it. Like the trade-offs are, there's this favorite thing we like to send around. There's this really old web comic where someone is talking about using MapReduce and Erlang. You remember this one, James? How are we going to solve that? Like the manager asks, yeah, and it's like, no, I think it's not XKCD, and the person says, well, we're going to use Erlang and do a MapReduce or whatever. And the manager says, I'm going to paraphrase here for trying to tone down the curse words here a little bit, but the manager says, did you just go tell me to screw myself? And then the engineer says, I believe I did, Bob. So I think that anytime someone gives you more distributed systems problems, anytime someone gives you more cache invalidation problems, you should really ask yourself, did you just tell me to go screw myself?
Right. That should send your spidey senses tingling, right? You're like, wait, yeah, that sounds like a layer
that one of those
systems.
Yeah, isn't that one of those 3 hard things I'm supposed to do as a last resort, right? Like I'm supposed to avoid like hell because they are truly complex. And so, the nature of moving compute to the edge usually involves pulling in a really complicated version of those hard things. And so it usually you shouldn't really strongly consider it till you really know you need it, in my opinion. In most applications, that's the right path forward.
I think you got to ask yourself, like, what are we solving for? Like, you have imagine you have a company and you have an application, and what are the biggest problems that you face? Probably the biggest problem you face is adoption and velocity of feature development. Probably the number one thing you can optimize for is how fast can you build features without restrictions, right? And the simpler you make your application, the faster you can move. And I can tell you, like, if you make your app an unnecessary distributed system, it is going to be insanely harder to develop on. Right. Yep. There's a reason people might have forgotten when Google announced Google Wave a long time ago, which was, a bit of a precursor to Google Docs, etc. It was like this insanely hard science project that Google did. It was like a huge fanfare. Like, look at what our geniuses put together. Right. That was a distributed shared text editor. Right. You don't want to go down that path if you don't have to, right? So number one thing you're optimizing for is like velocity and feature development. And number 2, sure, is performance, right? And performance matters, right? But then you got to ask yourself, like, what influences performance of your app, right? Sure, initial page load, that matters, right? But where is the latency coming from? Is the latency coming from like just a single round trip from your client to an API server somewhere and getting response back? If it is, and your app is like a something really basic, like a blog with a few little features, then maybe having it all running out of a CDN and the edge is for you. But for most applications, the slow part is the data interaction part, right? It's the many rounds of kind of waterfall style communication between your API service and the data. And so oftentimes it makes sense just to co-locate your compute with your storage. The one there's two things that can't move, right? Your data can't move, and you can't really ask your user to move either.
You could try, but they probably won't.
Yeah, you can try. Maybe Jamie.
Let's go to Virginia. It's beautiful.
You get 50 milliseconds every request.
Everything
That's right.
you'll go to Virginia, right?
That's
but
right.
You just got to decide what to put in the middle. And oftentimes the trade-off really is that the compute is better off next to your data, and the data is better off in a single location, and you get to avoid all the horrendous complexity that comes from doing otherwise. Now, there's obviously successful use cases the other direction. People have done like complicated, successful edge applications, but it's something you should probably only get into if you really know what you're doing and it matters to you. And one thing I do feel strongly about is should not be the normative way we recommend people start building web apps. Which I think is some of the blowback that's happened, I think, on Twitter, with regards to a lot of the changes in React and React Server components. We're kind of shifting the kind of normative, simple, hello world version of a web app to a pretty complicated thing and I don't think that's where people should be starting.
Am I thinking about this correctly then? If I have a server that is living on the edge and it has to do 5 network requests for some action, and its database is 150 milliseconds away, it has to do that 5 times, versus the server that lives in the same place at the data center, and it might take me 150 milliseconds to get there once, but that server can talk to the data in I don't know, 2 milliseconds or something like that, because it's co-located. So now instead of 10 times 150 milliseconds, it's 2 times 150 milliseconds, one there, one back, plus 20 milliseconds for all those writes. Is that so? Like the net benefit there is a lot.
I agree. Yes, I think your assessment of it's right. Like again, all the applications I've seen over the years, it's much more common, especially if you put in a little bit of effort to avoid request waterfalls from the browser, that you might really have sort of like 3 round trips you have to stack up after the SSL handshake from the browser. It's not great if it's 100 milliseconds. Fine. But realistically, the controller code often makes 20, 40, 60 requests to the databases. It depends on. And so the round trips didn't disappear. In fact, you have even more of them going from the edge all the way to the database. And so, yeah, a lot of times the actual performance benefit you get out of it might be negligible, or it may even, I think even Vercel recently posted a kind of a retrospective on a project of theirs that actually gets slower when you architect things this way. So to the point James has been emphasizing, like having the compute right next to the data ends up usually being such a massive performance benefit that like it's usually the safer default than moving the compute further away from the data.
Maybe we should define waterfalls just in case folks don't know. So a waterfall is a scenario where you have to do multiple requests in series. You can't do them in parallel. So one example is like you want to access some tasks for a user. So you first have to say, give me my user ID. And then you have the user ID and you say, give me all the products I'm a member of. And then you have your products and you pick the product you want. And then you say, now give me all the tasks in that project, and then give me all the comments in that project. And this is just a very, very common way of web development. There's other scenarios as well where joins, for example, look like waterfalls. But it's very, very common when rendering a website and fetching the data for that website that you have to do multiple round trips of data. And if you think that using GraphQL that makes waterfalls go away, no, it doesn't. The waterfalls just happen on the GraphQL resolver side, right? Like some entity has to do multiple requests in series. And because they have to be in series, you don't have the information for the second request before the first request is finished. That's why oftentimes an API service has to do 20 round trips to the database. Sure, you can try to architect your application such that you don't, but it's exceedingly difficult.
So as a developer, I spend what I feel like is too much time learning about new technologies and trying to understand if I need to apply this, if I should apply it, if I can just stick to the old way. I feel like I'm constantly inundated with this information. And that makes it tricky sometimes to understand what is necessarily correct for my use case. I feel like there is a bit of a feeling in the developer world where all the new thing is a hammer, and when you have a hammer, everything is a nail. And so I've tried to deploy things and put things on the edge. I'm curious if that is something I should blow up. Like, are there any use cases for a developer where we should still use the edge for certain situations?
Yeah. I mean, I don't want this to come across like that we're edge haters, because like the edge is just the technology, and it doesn't make a lot of sense to hate a technology, right? So I think edge is a very interesting technology. I think as it's presented right now, it's not a very good product. And the reason why, I think it just exposes complexity to developers that they generally don't need to deal with. I think, like, you see the march of technology, operating systems came along and people didn't have to think about like CPU architectures and interrupts and memory buses, right? And then the cloud came along, you no longer thought about running services and how they run and what OS even is running inside of them most of the time. And then you had services like Netlify and Vercel, amazing, the serverless movement, right? And all of a sudden you didn't think about DNS and routing and CDNs. Just kind of did its thing and worked. And that's great. I think every time we raise the abstraction floor, it allows us to focus on what matters, building stuff and building it fast and making.
Right. So I've found just by using, like, switching my applications to be hosted or run through Cloudflare, for example, I get all of these like pass-through benefits just from using Cloudflare, and I didn't have to study anything. I just kind of got them, and I like that. That felt good. It felt like they took a lot of complex concepts and applied them on my behalf.
That's exactly right. Like if they can take a complex concept and provide a simple abstraction to you, so you can just use it and it just does its thing, that's the ideal. Right? Because you don't want to hire probably don't want to hire a back-end team full of distributed systems engineers to figure out distributed data sync, right? You probably just want to build your application and have that platform solve those problems. And so I think when we kind of, people got excited about edge compute, we took a little bit of a step back, right? Everything got a little bit more complicated again. That abstraction became a little bit messier. Now you have to wonder where data is, right? So I think that there's a lot of promise from like the edge of the technology. I think that should be hidden away from most developers. That should be encapsulated by good abstractions that do caching for you automatically.
Yeah, I think the way that you said it just a second ago, James, is I hadn't thought about it that way, but I think that's a really good, a very succinct depiction of what the problem is here, right? So most things that feel like they really brought us forward, what part of what they did is they raised the abstraction level we all were operating with. And in many respects, the recent edge movement almost felt like it lowered it. We're like, wait, I thought the whole issue, I thought we were in a world where we don't really have to think about the server that much anymore. And like now it's like, it's time to think about servers again, and have that be deeply involved in the way like our front ends work. It's almost like if someone was like, I just made a great new operating system, and guess what? You get to worry about hardware interrupts again when you read, when you access the file system or something. You'd be like, wait, what? Like, it's crazy.
You'll get
right?
40 milliseconds of savings.
Yeah. You'll shave, 5 seconds off of your file access by handling hardware interrupts yourself in a spin loop or something. You'd be like, what? I don't want to do that shit anymore. So it had that kind of vibe to it, but that's different than, is there more the edge could do for us? Is there more it could do for our applications? I think that the answer to that is definitely but probably a lot of that work so that you don't lower the abstraction floor and cause application developers to have to defocus off of their application. A lot of the responsibility to take more advantage of the edge is probably going to be in the platform layers. So yeah, James was just mentioning like caching, right? So one example is like, database systems and storage systems that when data changes can get more involved in ensuring the right data exists at all the edges so that you are able to cache more dynamic data at the edge, So Now, that doesn't necessarily mean maybe you're running the compute there, but maybe you're just actually storing the final products that the browsers are using or whatever, right? So maybe you could do some last minute compute there. But I think that you kind of would love to have the version of that deliver as many benefits as it can without asking you to slow down shipping. Like I can think of very little circumstances where I would, as an engineering leader, would ever trade ship speed for performance unless I knew I had to. And that's the issue, is that the edge can do much more for us, but I think we should always shoot to have it do more for us without kind of undermining the progress we've made by having these powerful new abstractions that let us build applications more quickly.
Mm-hmm. Awesome. Great. Well, thank you very much. On that note, we can wrap it up here. I enjoyed having you answer all of my silly questions. I really do appreciate the insight. Thanks for the time today, guys.
Thanks so much.